Hi, welcome to part 4 of our text model refactor, probably be a more accurate name. So while you guys were away, we managed to wrap things up with sort of creating a common interface for all the helpers and changing all of the existing helpers to use that common interface, updating all the templates and so on, and got all of that code to compile, and we pushed that. So that's now done. I also moved across some of the profiles, as you can see here. Not particularly clean yet, but otherwise you can spend hours on end faffing around with graphical layout. Hopefully we'll get rid of that in the near future. So what we're going to do in this video is we're going to make use of the new chain instead of using the assistant. Well, actually we start by using the assistant, but the assistant will call the new chain. Let's make sure this doesn't... To be honest, this is a bit of a waste of time, as always, is playing around with the graphical layout. But there you are. So as I was saying, we're going to start making use of the new chain from within the assistant first. In order to do that, we need to register all of the helpers in against the new registrar that we got in the model, the common model, so that the chain can then run against those. And we probably need to change the signature of the chain as well. So that's that. And so in order to do that, and this is what we started, but we haven't gone very far yet, we need to start creating initializers for all of the facets. Now the reason why we're doing that is because we want to register the helpers via the initializer, so that it will be very close to the end result. So we've done one, which was the hardest, I hope, because it caused a lot of breakage. And now hopefully all we need to do is just do all of the facets across the two technical spaces. It's going to be quite a few of these. I mean, we're not really going to bother too much with layouts and stuff at the moment, because we're only really just going to add the bare minimum to get this to work. So I'm even going to probably just make these quite small, and then we'll worry about the rest later. So as you can see, there's a whole lot of formatters in here. We can't actually start adding the formatters. In fact, we would have a problem when we add the formatters. We will have to first create a common interface for formatters before we can add the formatters. As you can imagine, we tried doing that. The reason being that at the moment the formatters are using the technical space specific interfaces. You can see somewhere around here. Should be a top level. There we are, this guy here, and this has to be first moved over to here, so that they all depend on the same interface. And then once that's done, then we can start to add formatters one by one. So we'll leave that for later, because we are really focusing on the helpers now. So let's just not worry about that. We've done all the fixes that were needed in order to support empty facets, so that shouldn't be a problem. So what we're going to do then is go to the usual copying and pasting. It's a bit annoying really that we can't just properly copy and paste. But at the same time, this is a good time to clean up these comments, because some of these comments don't even make sense anymore. So model to text, transforms, forms for the hash facet. One thing I'd like to say as well is the world is going to look so much easier once we move over to our org mode models, because let me just show you. Oh, okay, sorry, I just tried to do something that was not very clever. So this is hash, if I'm not mistaken. Oh, we're there. Oops, a bit too green. Right, so that's got a name now. and while we're there as well, let's just give this the right color. Right, so now what I'll do is I'll just save this for a second, and then I'm just going to run the conversion to org mode. So what I want to show you, one day, still a long time to go, but one day we shall be able to edit the model, one day soon hopefully, from the org mode representation, which is the kind of the natural representation we concluded. So this exact same model from an org mode perspective looks like so. And if you take, say, the backend here, as you can see, we're still not quite finished here because there's lots of artifacts that are not quite right and so on. But at any rate, so if I open up the hash transform, you see the comment becomes the body of the entry in org mode. And what that then means is that, of course, we've got all of the usual org mode support, such as, well, copying and pasting for starters, but we also have syntax, well, error checking, I guess, so we can fix the errors and so on, right? So the document becomes more, the model becomes more of a document, a regular document. And of course you can then export this document to other formats, like for example you can create a PDF or an HTML of this document, which is great. So this is really is the future, but sadly we're stuck in the present. So for now we just have to keep going. So I'm just going to copy these guys across manually. Hopefully the next sprint will be all about moving to org mode, I think. So, okay, so hopefully, and also you can see here as well, there's a few things here that are not particularly brilliant. There's a lot of repetition here and so on. All of this will be resolved once we move to the proper physical model. But let's make sure we didn't make any mistakes. Directory name, physical postfix is a hash. Okay, that looks good. We will also need an initializer, which is the point of this exercise, really. Single operation. And we'll just change the color for good measure, just to keep it consistent. I think it's this guy here. Right, so let's go down a little bit to give it a bit of space there. And so what we need to then do is, sadly, just do a few of these, really. Let's just get them all done first. And one more probably. Not exactly right sizes here. Right, so also do the colors. Okay, so we've done hash, build, IO, and ODB. I suspect that we can, the comments are all going to be very similar. We weren't particularly creative. I mean, this is just the first phase of commentary. And then we have tests. Test data. one. So we then test data, serialization. Actually, to be fair, I'm just doing a tree of these, and then let's just see where we end. Right, nothing particularly brilliant, just enough to get us going. And we know that all of these are going to be facets. So we're kind of getting closer, I mean very slowly, but we're getting closer to our idealized setup, where you declare all these things in a nice clear manner from the UI. Well, the UI at the moment at any rate, from the model I should say. And then the code generator does all the binding of all these things together. Just not fast. This is one of the things we need to get used to. It's very easy to imagine what you need to do, but then takes many tests, data. Takes many sprints to actually implement something that looks pretty trivial from a perspective of planning. For instance, we just basically said, oh well, we need to merge these models, and it sounded like a fairly trivial thing to do. But in reality, to do it incrementally without breaking the world is actually quite tricky. Right, and that's C++. Well, that's the features of C++, should I say. Now what we'll do is, I'm going to be very cautious here and actually copy all the comments across and make sure we don't break anything. Because actually what we can do for the comments to make things a little bit quicker, just add them all in one go. In general, I'm not a big fan of having to do lots of manual work, but one thing that must be said is that this kind of work, it's we did forget. Let's just do these ones first. Seems like you. Oh, can you do more than one at the same time? Oh, you can. This kind of work is. Well, it's a bit boring. It does make you closer to the thing you're working on. Because a lot of the times you're just rushing and trying to get to the next thing, and so you never have the time to try to look at what you're doing really properly. Particularly when you have sprints and people are on your back, and you know things need doing quickly. Most of the time when you're working on coding, you need to rush. So these are model to text transforms relating to build files. Interestingly enough, we did not bother to set anything else, but as you can see, this is why we need to copy and paste these comments, because otherwise we would start causing havoc here. The other thing we can do as well, because we know for sure these classes are going to be, we could probably just add all of the initializers. There are ways of actually copying and pasting in Dia. When I'm doing something really complicated, I tend to actually use those ways. It involves editing the XML file. It's just not very nice, and because of that we tend to avoid doing that. Okay. Now, as you can see here, oh actually one thing you could have definitely done is set all the names in one go. I wonder if you can actually say no, we can't set the attributes, but it doesn't really matter. Right, so now then what we're going to do is make sure these guys here have the required space. The only thing we're really missing here is a bit of music. Oh, we know for sure that all of these guys we're going to need this comment in, otherwise it won't be detected by Dogen, should I say. So we'll just add that manually. Let's also make this a bit bigger. Right, so now then, all of them nicely lined up. And so what we'll do is, as we go along, in fact we might just do all of these guys in one go because it's quicker. No, that's not an attribute, it's an operation. Right, let's just do all these guys quick. Yeah, so as I say, this is may not sound like the kind of thing you want to be doing on a daily basis, and I guess it's not. And really, to be honest, this is really, once the code generator is up and running, once we've done what we should be doing, once we finish all these refactors and so on, there will be a lot less of this kind of work. The whole point of the code generator is exactly to find tasks like these and to automate them. Sadly, as you're bootstrapping the code generator, you end up having to go through the pain. Somebody has to take a hit, I guess. Right, cool, that looks good. So now all we're going to do is join these guys here, sensible, and then we just do the comments. So those guys, Codec, comments equals true. So what we probably should do as well is just increase the font a little bit. My eyesight's not quite as good as it used to be, I must say. Let's go for 90 perhaps, or even 80. Yeah. I used to always have very good eyesight, but these days I think I probably should be wearing glasses. I think it's the fate of all programmers, or at least those of us that started with really good eyesight. I did spend the vast majority of my life coding in the dark, and I remember being told not to do that because one day I won't be able to see properly. Not sure if my parents were right or not, or if it's just age. But at any rate, catches up with us all, I guess, time. Right, so as you can see, a bit of a few boring tasks here. And all we need to do is just make sure that all these guys have got their common stuff. So Codec, comments equals true. Yeah, so that this fundamentally this is the thing with programming really is. Part of it is you really don't want to be stuck doing boring work. The great programmers are the ones that automate things. But at the same time you don't want to automate something that is actually not required to be automated. Sometimes you just need to do something manually. Right, okay, so I think that captures all of the facets here. First pass, I guess. And now we've already added the comments all the way up to build, so let's go and capture the rest. So IO. These comments are all going to be pretty bland, pretty similar. Mode to text transforms for the IO facet of the C++ technical space, and then we just need to add physical directory name. Let's make sure we don't make any spelling errors here. Physical postfix equals to so you can easily see a few quite simple windows you can have here, such as, for example, we should be able to default the directory name and the postfix to the name of the facets, and in fact we have already got a story for that in the backlog, and the only reason why we didn't do that at the time was because there were some issues with naming the facets, and then we ended up having to do all sorts of hackery. Now that the facets are named correctly, so we should probably do that. There is also the case where we don't want that to happen, like for example for facets such as build, where there is no directory name and so on. So we need to worry about those sort of corner cases. But ideally you want to type as little as possible, really. So model to text transforms the ODB facet of the C++ technical space. Getting a bit repetitive. MASD.physical directory name. Underscore equals to ODB. Does not look like an underscore, but Dogen MASD.physical postfix equals to ODB. Right, so ODB done. It's interesting that in some of these we don't bother. Oh, I suspect this says there's some hackery involved here in the tests facet. Generate tests for generated in the C++ technical space. Right, so yeah, I'm quite sure we do some kind of hackery here. And I think, let's just have a quick look. Let's open up a new area here, perhaps 20. So if I go up to C++ ref implementation integration, let's call this C++ ref info code. But if I have a quick look at what we have here, I think you'll see any of these probably. Here we go, it's called generated tests. So what we'll do is we'll do what the right thing should have been, which is okay, sorry, my OCD nature. I don't want to have this. Right, so there we are. Now this probably will require a bigger space, but there you go. So this will now point to the right thing, such that when we are actually generating this thing, it will do the right thing. Right, so something like this. Let's move these guys a little bit. I mean, we're going to have to resize these things 20,000 times, I think, because we're going to have to add the formatters to it. So make sure we deleted the comment. We did. Right, next, test data. Okay, so this is not that physical. Test data. And that is the postfix we use for the test data files. The postfix is an interesting feature we had in Dogen. To be honest, we probably should test these things again. In the beginning, I mean, Dogen started a long time ago. Well, when we were generating files and we were running coverage, one of the problems we found was that if the files had the exact same names in different directories, lcov, I think, whatever the coverage tool is that we're using at the time, got really confused, frightfully confused. And so because of that, we created this idea of postfix where files in different directories with the same name would have a different name. So all text transforms for the boost serialization facet over C++. We're using capital C++, aren't we? For the C++ take space. There's another interesting comment here that we should make about serialization. So again, because Dogen has been around for such a long time, in the beginning we gave names such as serialization to facets, and then what we realized actually is that there are two distinct concepts. There's the serialization notion, which you probably want to have on a user model. But then there's this notion that you have a codec for serialization. Now I don't mean codec in the same sense as Dogen codec, or perhaps I do, I don't know. But basically what I'm trying to say is that there's many different ways in which to serialize something. So it could be JSON serialization, it could be XML serialization. I mean, there's about 20,000 different JSON and XML libraries in C++. And so all of these things could be deemed to be the serialization facet. So what we did originally was just to call it serialization, but it's just almost as soon as we've done that we realized that actually perhaps calling this serialization doesn't make a lot of sense. So one of the stories we have on the backlog, So one of the stories you have in the backlog is to have two separate concepts. One concept is the name of the facet itself. So in this particular case will be something like boost serialization. And then the other concept is how that facet gets expressed into the user project. So you could call it, for example, BS, or you could call it serialization if there's only one in your project, and so on. And that's actually how that's going to end up being implemented once we get around to doing that. Because if everything goes according to plan, there will be lots and lots of different types of serialization methods. So let's double check we're actually recording. We are 28 minutes. So as an example, we are in the lexical cast facet, and clearly there could be a standard lexical cast, it could be a boost lexical cast. And so because of that, we shouldn't really have the name such as lexical cast, because it's a confusing name. Right, so after all that pain, we've managed to create all of the initializers. And like I said, this is all going to change in the future, in the very near future, but there you go. What we really want at the moment is just to create all of these chaps. So what we'll do is, as a first go, we will just it's interesting that we decided to call this model to text C++ chain. Really we should give it a name like actually, to be honest, this is just temporary because we as part of the backend we'll generate the actual model text transform, so that doesn't really matter. Right, cool. So what we'll do is we'll just do C++ first, and then we will do C# next. So let's just see what the code generator said for itself with all of this stuff here. So we want to just, well, make sure we are in the latest. We are. Then we're going to code generate this. And for good measure, let's just try to run all tests, because we may have generated some invalid code. We are trying certain things for the first time. That's actually not looking too bad. These are the org mode transforms that we're gonna sort that in a second. A bit of luck. This all compiles nicely. So text add all facets to C++ technical space. Ooh. And since we've done all these changes, I'm just going to regenerate the org mode models since we're going to commit these. And then with this you get fresh org mode models. So org mode models. Occasionally we need to do this just to keep them in some kind of line. Right, cool, that was it. Now for good measure, let's just, since we're doing the boring stuff, let's just do the C# stuff now. So C# then. Well, for C# we need to do something like this. Let's try to give it a similar color, so EDF. And the name should be, right, so this is where we start to have to be careful. The name should be C#, and that's exactly the sort of thing we're trying to fix, these mismatches. And now we can drag it across. We're going to put them side by side, I think. I mean, you could put them one above and the other one below. Not sure what's more readable. I'm going to go for side by side because these models are going to grow a lot downwards. So, and like I said, this is all concerns we only have because we have a graphical representation at present. So let's not get too hung up on it. Right, so what we need is to copy and paste comments. The reason why we are making sure the comments look rather identical is because there's a lot of incantations in these comments you can see here, and we don't really want to be troubleshooting minor configuration issues, so we just want this to kind of work. Try to fix a few things in the text, but otherwise never quite sure if we should use capitalization for technical spaces, but there you go. So text types in the logical model creates text representation. These types according to the grammar. I even find it difficult. Oh, the C# technical space. I even find it somewhat difficult typing outside of Emacs these days. It's weird because, of course, most of the time you're just typing text, so it should be the same things. But your brain is just so geared towards typing in C# in Emacs that when you change things, I guess the neocortex is just finding it weird that we're not in the same place. Right, so a lot of things here that need to be updated. Like you can see, I'm writing the word C# about 20 times. Also, there's this silly directory name of CS. We should really not have done that because this just generated a mismatch for no reason. We could have just put the name the same. These are the sort of things you do when you don't really know what you're doing. And then they may have very large consequences. Right, so the next thing, which is also a particularly boring thing to do, is you need to copy all of these profiles. I did consider, and this is why I have the profiles model there, I did consider making these profiles common across across all a number of models. There is something to be said for that approach. However, I went against it in the end because the profiles in the profiles model are actually common across more than one model. And these profiles are specific to the text model. So by the end of it, it seemed to me we were just being lazy, really. Right, so what we did is 1, 2, 3, 4, 5. We need 5 more of these. One more. And then what we'll do is we will just get all the common settings. Which is the stereotype and the color. Not quite that color. PDE. Okay, that looks right now. They look very similar to the background. Now I think in C# every single one of these descends from a common type, so it should be very simple. And now for the boring parts, lots of copying and pasting. Really rather boring. It's almost, I guess, a test of endurance. And you could probably say, well, why are you going through all this pain instead of just moving to org mode? But what we must understand is that if we were to, every time we have an idea, if we were to act on that idea, we would have so many concurrent refactorings in place. I mean, it's not that we haven't tried this in the past. We have tried every time we were doing something and had ideas of how to make that something better. We tried to make a little spike and then just quickly implement that idea and then go back to where we were. And to be fair, this worked well in many cases, but it also meant that we kept losing concentration. We kept starting something, thinking, okay, I think I know how to implement this, only to then find some spike to get lost in, and then after a sprint or two realized, okay, what exactly were we trying to sort? And then the other problem as well is that sometimes you optimize for, you do a local optimization. This is another very important thing. For example, you could do a local optimization that solves all your problem with helpers, but then you may then, as you are progressing, you may then realize actually you don't really need helpers at all, and so you don't spend all this time optimizing for helpers only to realize that actually there was a fundamental modeling error in the way you designed the system, and the thing that you spend so much time optimizing for is actually not required at all. And so because of that, sometimes it's better to do the boring things and to keep doing the boring things, even though there are definitely much better ways of doing it. Not all the time. This is not a general principle. It's just that you have to determine. You have to somehow determine. You should try to not have too many things on the go at the same time, basically, because it becomes quite difficult to remember, to keep state in your head. That's actually one of the biggest problems of an open source project, I think. And so sometimes it's better to just do something that's not particularly brilliant, but it's completely trivial to implement, even though it could take a long time and even though it could be extremely boring, rather than get lost in an infinite loop of improvements. Provided you can see it through, of course. I mean, if I knew that for the rest of my life I would have to be copying and pasting, I can assure you that we would not be doing this. But since I know this is just a temporary thing that we're going to resolve in a sprint or two, That then means that I'm not too bothered about doing it right now. I think that's one of the things that just learning this level of patience. I don't think we, as developers, we don't really, the new school of development is really very different from when I learned how to code. Because I think one of the main reasons is when you learn how to code, it's good to learn how to program when you're quite young. And that's not to do with anything. It's not to do with the fact that when you're young, your brain is more plastic or nothing like that. I think anyone can learn how to program. I've had many friends that learn how to code in their 20s and 30s, and they're very good developers. A lot of them better than me. But I think part of the process of programming is to get used to not boredom, but tasks such as these. Just do this without getting stressed, without worrying too much about anything else, and just getting on with that and doing the next task, and then doing it properly as well. And I think the people that learn how to program from my group, the people that were young in the 90s, because we had to do so much boring stuff, I mean incredibly boring stuff. We had to copy things from magazines, and I think it will be very difficult to explain to anyone from the 2000s just how painful life used to be in the 90s and the 80s even. And so, okay, we didn't have to face punch cards and that sort of thing, so I can imagine that will be really, really challenging. But at least we got to enter programs in machine code into not PCs, ZX Spectrums and whatever. And you could spend a week typing hexadecimal code into your PC, and you're not allowed to make a single mistake, because if you made a mistake on the hexadecimal code, which was a machine code, you would quite likely the game would not start, and you'd have to restart all over again. So we used to have these massive listings, really humongous listings of hexadecimal code. I thought I copied that across actually. I did. And our job, in order to get access to games, because of course in those days it wasn't so easy to copy a game, even tapes, these games were in tapes, audio tapes, and tapes cost money, so unless you could afford to buy the tapes and you had the equipment to copy things across, you wouldn't be able to replicate the game. So it was easier to actually type the game, because one thing we had, which was free, was time. So you could spend a whole week typing, no one would charge you for that, but in order to buy a tape and in order to copy a tape, you'd have to have physical cash. So it was easier to actually just type a lot. So a lot of us became programmers, more out of necessity than out of interest, I guess. Just that we kept typing these things and we kept copying these games. Some of the games were in BASIC, some of the games were in machine code, some of the games were in assembler. And you keep typing these incantations, and at some point you just become curious, don't you? What is this thing you're typing? And then you start copying and pasting things from one game to another, and then you start trying to work out how things work, and that took us on a journey. And these days I don't think it's possible anymore to go on these kind of journeys, because, well, in some ways of course things are much better. I mean, don't take me wrong, the world now is much better for programmers. I mean, you get the best tools ever, at your fingertips. You don't have to do anything. We did a slight mistake here. Very annoying mistake even. We got distracted, and that should have not gone into the top level space. Let's think about this for a second. I think the idea here is that we're trying to make a single combined configuration, but that's not going to work, so there's a problem here, quite sadly. Now I don't particularly want to... Okay, so this is the cases where sometimes it's better to just edit the XML. So I'm going to demonstrate to you how you can edit this XML, because in this particular case this is actually quite a simple edit, I think. So what I'm going to do is I'm going to move all these guys to right, that's probably most of them at any rate. So I'm going to move all these guys into this into this namespace here. Now, as I said, Diet does not have a command to do this, so there's not much you can do. Let's just stop here for a second. Let's just make a bit of space. So what we'll do is we will just drag these guys down a bit. Make sure we have enough space for the stuff that's coming. Right, so then, yeah, so as I was saying, I mean, I don't want to sound like an old-timer trying to imply that somehow we had it better, because really, if anything, I'm very jealous of the kids these days, because I certainly would have wished to have access to, say, the kernel source code when I was 12 or 13, because then I think I would have been a real programmer. I think I would have been a very good programmer if I'd done that, because I had the curiosity and at the time, and if you had access to a PC in those days, you would learn all these things. And also the fact that PCs are so cheap these days. I mean, you can get a Raspberry Pi for not very much money, which then means that you got all the tools, best compilers, you know, GCC, the same compilers the kernel developers use, great distributions like Debian. I mean, you got pretty much all the things that I dreamed of when I was a kid is available to pretty much anyone in the world now. And now the problem really is how do we teach these people, so people from my country, in Angola, for example, how do we get them to use all these tools, because they don't even know all the stuff that's available to them. People without very much money these days could become top developers, and that's one reason I think why you're finding that. Okay, I think we broke something here. One reason why you're finding that there's so many good developers coming out of the third world now is because if you have the motivation and you have a little bit of money, I mean, you still have to be, you know, you still have to have access to electricity and so on. But a little bit of money, not quite crazy amounts of money like it was in my time, you can now actually learn pretty much everything. So that's really good. Right, now then. So now the problem is, Dia thinks that this belongs to that namespace rather than this namespace, so we need to fix that. So what we're going to do now is this. We're going to have to close a few of these guys. Make sure we save this, whatever that is. And what we're going to do is we just need to locate two things. We need to locate... now we don't want to do this blindly, because as you can see here, there's some types that are in the right namespace. We just want the types with the word profile that are in this namespace to go into this namespace. So let's make sure we saved. Let's go over to our models area, and we just need to open up the Dia models. Save here. Pretty sure I saved everything there was to save, but so if I go to text, now I don't like doing this very often because it is a bit tricky, but so what we need to then do is to just basically start messing around with this diagram. Should be only one layer, as you can see. Oh, actually, the other thing we need to do before we forget is to make sure we are in XML mode rather than an XML mode. No, we don't really want to be in XML mode. See what other modes there are. We want to use the plain plain XML mode because HTML mode because an XML mode for whatever reason in very large documents goes a little bit crazy. Okay, good. So we're now in plain XML mode, so now we can just enable AJS minor mode. It's just a little bit faster, it seems to me. I may have disabled AJS minor mode. Interestingly enough, I don't seem to be able to use AJS minor mode. Yes. Hide. No, it doesn't seem to be compatible, sadly. Oh well, right, now then, let's just get cracking with what we want to do. So, first let's just look for the backend. So here's the physical backend, whose name is C++, right? And its object is 041. Okie doke. Now, all we need to do is to locate all the profiles. So MASD variability profile. Let's go to the first one, and now very carefully we need to make sure we're in the right profile. So the name base archetype configuration, that sounds about right. Okay, so this is one of them. And then if we were to look for child nodes, I think what we find is, it tends to be the case with Dia, that most of these things are next to each other. So I suspect here we are, test configuration. So these are all going to be in a sequence now, I think. So all I'm going to do is look for the child node, and once I locate the profile, look for the child node. That's done. Next. As you can see, the profile is just here. And then there. Profile is there as well. Now, I don't particularly recommend people doing this sort of thing because, as you can imagine, it's very easy to break a diagram. In fact, it's yet another reason why we need to move away from this approach. So there you are. This is just insane, really. Now, what I'll do as well is, I think let's have a look at these generalizations. I wonder if they also have a child node. They do. Okay, so let's just get these generalizations all in the same namespace. Degree of belief here, to be fair. That we are doing the right thing. Because we can't really tell which which generalization we're touching. Right, now we're doing a class. Now we just have to be very careful. Object implementation configuration. That's a profile as well. That's probably this guy. Another class, primitive, that's fine. Enumeration. Now we have the generalization for it. Not quite sure what's going to be the halting function here because we don't really know. But as you can see, now we have a large package, so I'm going to assume that at this point we're finished. Right, so there you are. So what we do is we close this guy, open it again. Give it those rulers, they're quite annoying. And now, if our job was done correctly, what should happen is, yeah, these guys are now part of the package. Now, of course, because these things are not actually generating anything, we won't be able to tell the difference between being part of the package and not being part of the package. if this was actually an entity which generates code, of course the result would be that this will be placed in a different namespace. But these are profiles. Profiles are sort of configuration elements, so they don't generate anything. Yet, we just like things to be in the right places. I mean, not to say that we may not actually at some point merge these into a single set of profiles, because it's a bit annoying to have C# and C++ profiles. But first we need to make sure they all make sense. And I think that there's much work to be done in terms of cleaning things up before we can merge the profiles. So let's put these things vaguely where they were before. There is some method in this madness. Right, so that's the backend. Let's get the configuration. That's backend specific. There's the top level transform, which is a temporary thing for now. Just gonna leave it here. It's config and then the facets. Now these guys can go where they were before. Not expecting to move things too much in the profiles level. Now we're doing for time, so just about an hour. Right, so the objective of this part then is becoming clearer now. We're just gonna get all of these things done. Oops, I think we just lost the plot slightly here. Well, not that it matters really, but I mean, if there was some kind of order here, I suspect we should try to keep it. No, I have no idea what the order was, so I'm just going to randomize this. That seems sensible. Right, there we are. And then perhaps we don't need so much space at the bottom. We still have C# to sort out. Okay, so now we fix that annoyance. We can resume the actual thing we're trying to do. I think there is a bug that doesn't allow us to create an empty facet, an empty back-ended mode, so let's not try to regenerate just yet. I think that was, well, to be fair, let's see if we can regenerate, because if we can, it would be nice. So that we have a nice commit that encapsulates the namespace changes. And that will be nice. Let's see what the code generator says. It might actually generate. Oh no, it didn't. Okay. The reason why it didn't is, and yet another hack that we need to do here. So we need all these guys to have unique names. This is going to require sort of a suspension of disbelief yet again. Ah, okay, interesting. Built-in configuration was not copied properly. So let's open up the text models again. Right, so the built-in configuration was lacking. One thing I think that we did not check. No, that's correct. So the built-in configuration was lacking a few properties there. And as I say, all of these guys have to have some kind of unique fudge, just to make sure the code generator is happy. And we will have to address that issue when we get there. Now I think this will compile, sorry, this will not compile because I suspect we generate some invalid code here. I think that's, oh, that surprised me. What? That's not too bad. So it's definitely a commit. So text and C# backend and move C++ profiles into C++ backend. Okay. So of course you probably would complain and say we should have 2 commits for this, but there you are. It is what it is. let's get on with it. Make sure you're not being contacted. Nothing particularly special. Right, where are we then? So what we're lacking now, as you would have guessed, is the C# equivalent. So we need 4 facets. So let's just go for the usual. Perhaps you can get away with making this just a little bit taller rather than wider. Backends, never quite remember. I think backends are a slightly lighter version. Oh, sorry, not backends, facets. And then we know for sure that all of these guys have the same stereotype, so that will get us somewhere. That's just a little bit too big. And then, of course, we can create 4 of these guys. So as you've seen, we could, if we wanted to, go for the old copy and paste and modify the namespace. But actually, that is just a little bit tricky to do that, and it is very error prone, and we could result in a damaged diagram and all sorts of annoying things, which of course, as you can imagine, we've done in the past. So really the general conclusion is ideally don't do that. Right, so then we have managed to get a few of these things in. And then of course we know for sure we're going to need a Dogen MASD.codec.dia.comment equals true. I mean, if you don't, if you're wondering why we're doing this incantation here, the codec, the dia codec, it's yet again another dia limitation. The problem is, if you open up one of these guys, there is no comment. There is no comment here that you could use on the entity itself, which to me seems like a limitation of dia rather than anything else. And also illustrates what I mean about not jumping the gun. So we could have, and you would probably say we should have. We could have contributed a patch to dia to add comments, and we did consider that, and we have a story in the backlog for that, and we were close to thinking about implementing it. This was many moons ago, but what we did instead is we said, well, is there a quick workaround you can do just to get us going? And as it turns out, there was a quick workaround, and the quick workaround was what you see now. We just added a metadata flag that tells Dogen to read this comment as if it was the comment of the enclosing space. That workaround was very easy to make, and as a result, it saved us from having to do a feature in dia. Now, we could have done a feature in dia, which would have been the right thing to do from an open source perspective. However, it turns out that dia is actually not strategic for us. So it would have taken us a while to do that patch. It would have taken us a while to get that submitted. dia is also not very well maintained these days. So it would have been a rigmarole of effort. Or you could do the smallest possible, quickest thing you can do and move on. Sometimes the quickest thing is very dirty, not very nice, but it's better to do it until you know for sure that you're doing the right thing. You only have so much resources, and in order for you to get to where you're going, you need to preserve energy, basically. make sure you're doing the things that are actually going to contribute towards the end goal. And that's why sometimes the thing that is actually logically the right thing to do ends up being not the right thing to do, purely because you don't really know if that's going to contribute towards the end goal. So I'm just going to do the usual boring copying and pasting. So directory name is dumpers. It's interesting that we don't seem to use this all the time, the directory names. And we seem to have missed the names of the facets as well, so let's do that in a second. Right, so what's the space for this? Something like this perhaps? And there you are. So this is probably types. In many ways this has been a very interesting learning experience, because the coding you do for these kind of projects is so different from the coding you do at work. So a lot of the things I'm telling you right now are things that I've learned, not things that I knew already. If you take the usual approach that you're taking from work, you'll struggle. After all, it's work. You probably have a big team, and suddenly you're a team of one. So yeah, these comments are rather repetitive, and you probably were asking, why are we doing this? Just make sure I'm not making mistakes here. Yeah, these comments are rather boring and repetitive and not adding a lot of value. So people like Kelvin Henny would probably tell you, don't write a comment that is trivial. But part of it is that we're exercising the functionality regarding comments, which is important, make sure the code generator is doing the right things. The other part of it is that we need to actually go back and actually fix these comments, and oops, we don't need any more here, and actually add some kind of technical description of what each of these things are, each of these facets are, because what's going to happen in the future is that the comment that you put here for the facets and for the backend is going to be dumped in the command line as part of the description of that thing. So whatever text you put here, this text is also the description that then is going to hit the physical model. I mean, it probably doesn't exist yet, but in here there would be a thing called description, describable description, and that description may already be there. In fact, that description is the text that you're putting here. So as a user, if you want to know what certain facets do, you're going to rely on this comment. You're going to do a minus help, and you're going to see those things coming through. In fact, let me just quickly demonstrate this to you. I think, so if I just go up to build, output, release, release, stage, bin. So in here, there should be something like Dogen CLI, minus help. So one of the things you can do with Dogen is to ask for one of the modes, the dump specs. So the dump specs at the moment, it probably doesn't do anything particularly clever, to be honest. So these are dump specs as you can see here, we love org mode. The tank specs at the moment just gives you a org mode dump of everything that's inside of this this code generator, and as you can see here, it's already giving you things such as the codecs. So if we were to look at a dia codec, I'm not sure if this has been implemented or not, to be fair, but let's have a quick look. What we'd expect to see is that the comments, in fact it's not yet, but this in the future, what you see here is what is going to be dumped here. So at the moment there's got this thing here, but in the future that's not what we're going to do. And similarly, we're going to have another entry here for the physical model elements, which doesn't show up yet, which will tell you all the backends and so on. In fact, we already have some kind of entry here, but I don't think it shows you all the facets yet. So all these things are going to show up here. Once the physical model integration is complete, we need to just add it here. And that's going to be quite nice, because as a user you can then see the documentation for the code generator, which was generated by the code generator itself. So that's why this is important. It may not appear right now, but it is planned to take a very significant role. And of course, when we move to org mode, writing documentation will be significantly easier. So that's a bit of an explanation as to why those things are the way they are. So what we've done now is we finished the initializer. So let's then go back to our code generation, and let's just try to regenerate the model. One thing we said we were going to do, we never did, was to finish the facet name. So test data in Visual Studio. So one thing I'd like you to also bear in mind is, so I've spoken in the past about projections across logical physical space. Facet is part of the physical representation of a logical projection, and a facet as an entity actually shares a presence across technical spaces. This is something we haven't developed, the theory behind this we haven't developed very well. But when you see the types facet in C++ and when you see the types facet in C#, actually those are the same types facet. As that facet is projected across different technical spaces, it may change some attributes. And part of the work that needs to be done in the logical physical model is exactly a description of this notion of identity of facets across technical spaces versus the fact that there are two different representations. So we need to create a good solid theory behind it, but that's why you see the facets here having the same names, but then they project to different physical representations. So this has got a different folder name, and for example test data is called a dumper. I don't know why, but at whatever time we thought that was a clever thing to do. And so those are that is the rationale behind the facets. So now it's going to create a whole load of facets here, as you'd expect, and then we should just hopefully compile this. I'm not sure if I've been running the test, so we should probably do that. What are we doing for time? So we are an hour and 14 minutes into it. I think to make these videos a little bit less long, we're going to try to have an hour and a half maximum in each video. So I'll be breaking soon. So what we'll do there, we'll just basically say something like add all facets to C# backend initializers. Okay, cool. So that's good. So we quite quickly managed to get that done, which was good. Now, the next step is going to be to implement these initializers, right? This is going to be something we're going to do next video. Right? So what have we done now? We've basically on our objective of merging all the different text models into a single text model, we've now created all the facets that exist in all the text models in each of the backends, all the backends, of course. We should probably fix this. level OCD will not allow me to leave this here. So so as I was saying, we have merged. Well, we've introduced the backends in the merged model, the text model. We've introduced all of the configuration. This is going to be a whole other kettle of fish because we're going to have problems with that, but we'll address that when the time comes. Those names have to be unique, so there's a problem there. And we've copied across most of the top level infrastructure really. If you look at this guy here, what is left is actually not supposed to be copied. Is all this common infrastructure that we don't really want to copy. And then of course the bulk of the work is going to be the individual transforms. And so the next stage of this work is going to be to get all of these initializers to initialize the helpers in the chain, and then to get the chain to run through all the helpers. So the first stage, because we do this everything very incrementally, the initializer is actually, in a very hacky way, it's going to be initializing against the helper that already exists, and that's fine. But in the second step, what we'll do is we'll just very, very carefully move the helpers over to the text model. And that should be fairly straightforward. I think it's literally a copy and paste job. You just have to copy everything here and then change the initializer. And then in theory nothing should have to change, and we can just do all the helpers in one go, and that will be the end of the helpers. And then same exercise would have to be repeated for the transforms. Much more complicated of course, because we first need to create a common transform interface like we did for the helpers and so on. Okay, so that's all for this part, and the next part would all be about moving the helpers. Thanks for watching.